All right, so we're going to be talking about normal distribution. And we've already talked about this. We've done a lot of things with it. This is just a quick hit of what to do now. So for each question, we're going to construct a normal distribution curve and label the horizontal axis, then answer each question. So the very first thing you do is take the given information and label everything. You'll notice for every problem on this page, I've given you on the first part of the worksheet, I've given you a picture that you're just going to label. And then on the third page, you just have the one picture, and then you'll have to draw your own or just label and erase, or label and erase. Whatever works for you. So we'll start with number one. Line up for tickets to a local concert. Had an average waiting time of 20 minutes with a standard deviation of 4 minutes. So 20 minutes goes in the middle. And then add 4 and to move up, 24, 28, and 32. Subtract 4 to move down, 16, 12, and 8. And so what percentage waited in line for more than 38 minutes? So the next thing that we have to remember to do is put the percentages on. So that means we're going to be using the 68, 95, 99.7 rule. And so 68% is this portion, 95 is this portion, and then the final portion is all the way there. So so more than 28 minutes is this part. These two are both 34 minutes. That's half of my fingers. Not doing a great job here today. 34 minutes, 34 over here. Then we've got the 95 minus 34. These are both 13.5. And then these are both 2.15 and 2.35, excuse me. And 2.35 with the last two areas over here and here being 15%. 0.15. Okay, so for more than 28 minutes, that's 2.35 plus 0.15, so that's 2.5%. If 2,000 ticket buyers were in line, how many of them could expect to wait for less than 16 minutes? So less than 16 minutes is 13.5 plus 2.35 plus 0.15, which is 16%. This is where it gets a little tricky. So some of these problems aren't quite as straightforward as the ones we were practicing before. So 16% of 2,000. So that just means 2,000 times 0.16, which is 32. 320, moving the decimal place twice after multiplying. So 320 people would wait for less than 16 minutes. We just double check that calculation with the calculator. Clear. 2,000 times 0.16. Yep, 320. So that's that. Again, it's pretty straightforward. This is the new twist. Is in some of the questions I'll give you a number and expect you to use the percent with the number. Pretty much the only trick. So the Oreo factory mass of cookies were produced within 2 grams of the mean. Keep that in mind. See what that is. Remember, our standard deviation is 2, so that just means within 1 standard deviation. That's 68%. You don't even have to do anything. 68%. Then do that times 1,000, 10,000. And then this one you'll have to figure out everything before you move on. Speed of cars on a highway. This one's pretty straightforward. This one I thought was a little interesting. And so let's go ahead and do this one together. So we're on number 4 now. The mean life of a battery is 50 hours with a standard deviation of 6 hours. So again, we'll start with the labeling. This is 50. Standard deviation is 6. This is 56. 62. 68 out here. Going the other direction. 44. 38 and 32. And so they're going to replace all batteries that last less than 38 hours, that's right here. These two together make 2.5%. And so 2.5% of 50,000 so that's 50,000 times 0.025. And so I'll just grab the calculator right away. So our calculator is 50,000 times 0.025, which is 1,250 would need to be replaced. Continuing, you have question 5. A bottle of fruit punch contains at least this many milliliters. The machine that fills the bottle is set so the mean volume is 477. The volume of bottles is normally distributed. So part A says what percent of the bottles are underfilled if the standard deviation is 2 milliliters. And then part B is the standard deviation is 4 milliliters. So you notice that I've given you 2 different curves here because you have to basically build it twice. And so we need to have at least this much for it to be. So we're looking for numbers under this to be underfilled. So set them up, see what happens. So that's what I would expect you to get done in class. And then the last page would be your homework. Depending on where you are, because the whole thing will be turned in on Monday as a homework assignment. So get done what you can. Population of NBA players is normally distributed with a standard deviation, with a mean of 6'7" and a standard deviation of 3.9 inches. This is according to Wikipedia, about 5 years ago. Greg is considered unusually tall for his high school at 6'2". What percent of NBA players are taller than Greg? What percent are shorter? And how tall would Greg have to be in order to be in the top 2.5%? So the top 2.5% is this part. So that's what you need to figure out there, is to be in the top 2.5. So the bottom 2.5 is the bottom 2 sections, top 2.5 is top 2 sections. If you think about the 95 rule, they got 5% left to get split between the two. So that's kind of the idea here. And see how you can do this. Is the only trick one is this part C. And then they have you do this next problem is still Greg. The average height of the boy at Greg's school is 5'6" with a standard deviation of 2 inches. If we assume the population is normal, what percent of students in his school is Greg taller than, and what percent of students are between 5 foot and 5'8"? And so that's where you'd be looking, again, rebuilding the curve, answering those questions. Question number 3. Excuse me. Jordan is drinking a cup of hot chocolate. From previous research, he knows that if he takes a cup of hot chocolate, an average of 10 minutes to reach the temperature will not burn his tongue. The time it takes to cool varies normally with a standard deviation of 2 minutes. So then you've got 10 minutes is the mean, 2 minutes is the standard deviation. How long should he wait if he wants to be 84% sure that he won't burn himself? And so if we think about our numbers and our standard deviation, and just the 68.95, I'm just going to write down the percentages. 2.15, 35, 0.15, 13.5. So each section, 13.5, 60, 34, and 34. So this is the bottom numbers. So we know these two make 68. These three make 16. And if you add 68 and 16, you get 84%. So we're looking for the bottom part of the data, leaving off the top 3 spaces. So that's what you'd want to look at, is what's working on that. If he only ends up waiting 8 minutes, what percent of the time will his tongue get burned? And that would be, you'll have to build the curve and see. So that's your basic idea. Good luck today, and I will see you all on Monday.